Okay, so let's go ahead and take a look at this last problem, number 50. Number 50 states, identify the axis of symmetry for the graph of f of x equals 2x squared plus 4x plus 2. Okay, so a couple of things here. Just a reminder that axis of symmetry, that's kind of that center line where it's the same on both sides. So let's just do a quick review, and then also what standard form is. Okay, so if we take a look, and I'm just using this as an example right here, just an example. So here we have a parabola, and I just made it up. That's all I did, with a vertex at 2, 1. All right, so it's opening up, it's a minimum value. The axis of symmetry is going to come right down the center, right? So if we were to fold along this axis of symmetry, then this left side of the parabola would match up perfectly with the right side of the parabola. The axis of symmetry always goes right through the parabola, through the vertex. So this line of symmetry right here, then it has an equation. All right, so you can give it an equation, and this will be x equals 2. Okay, so that is the equation of the line of symmetry. The line of symmetry is not just a number. So that's a common mistake that students make. It's not just a number. It's not just 2. It's this full line. All right, so it's x equals 2. And notice in this particular, with this parabola that I just made up, that the vertex here, I'm going to bring it over here, is 2, 1. So it's going to be the x value of the vertex. All right, so my x value, the h right here, well, that is going to be where the line goes through. Therefore, your line of symmetry, the equation is x equals 2. Okay, so make sure that you know that the line of symmetry is an actual equation. It's not just a number. All right, so you're also, it's asking you to find the line of symmetry for this function, but the function is given in standard form. It's not in vertex form. Well, it would be nice and easy if it was in vertex form. So just a reminder that standard form is f of x equals ax squared plus bx plus c, where your variables, right, the exponents are in descending order right here. So here it is, and that's what the problem is given. It is given in standard form right here. Okay, so I don't know if you remember this from your book, but to find the h, okay, so again, that is your h right here. I know I have paper over paper. So that is your h of your vertex. So to find the h, that's your x value of your vertex. All right, so to find h of the vertex, when the function is in standard form, then this is the formula right here. Okay, it's just take the opposite of b all over 2a. And the way you get the b and the a, you just come back over here in standard form. So the a would be the coefficient in front of the x squared. B is the coefficient to the x. And that's it. That's where you get that. The formula kind of derives from kind of those first terms. Well, the first term and then the denominator of the quadratic formula, if you recall that. So that's where it comes from. I'm not going to get into that, but you probably want to put this on your index card, I would imagine. So that's how you find that the h value, okay, of the vertex using this opposite of b over 2a. Okay, so I'm going to set this aside and let's go back to the original problem here. Identify the axis of symmetry for the graph of this function that's in standard form. So we want to find the x value or the h. All right, so here's the vertex, hk. We don't know what it is. We're just interested in the h. all right? Because we know the axis of symmetry is going to go through the x value or the h. So let's come on over here. We're going to use the opposite of b over 2a to find that h. So right here, the opposite of b, here's the b, coefficient of the x, it's the opposite of 4 all over 2 times a is the coefficient to x squared times 2. So therefore it's going to be negative 4 over 4, which is a negative 1. That works out nice and easy. All right, if we wanted to find the k, right, if we wanted to find the full vertex, then all we would take, remember this is just the x value. We found the h, right? There it is. We found that x value. H, remember this is how we get our h right here. So we just take that negative 1. We could plug it back in for x, right? And just put negative 1 in here, negative 1 in here, and then go ahead and solve it to find out what the y value or the k value is going to be, all right? So that's fine, but just as long as you know, you would just plug the negative 1 back in right here, find the answer, and that would give you your y value, all right? But I'm going to go ahead and do that just to be on the safe side, and you can skip it if you want to. So I'm going to come down here to find the k. I'm going to take f of x right here equals 2x squared plus 4x plus 2, and I'm going to plug this in. That's my x value. So f of negative 1, I want to find the value of this function when x is at negative 1. So 2 times negative 1 squared plus 4 times negative 1 plus 2. And then go ahead and just figure that out. Negative 1 times negative 1 is a positive 1. So we have 2 minus 4 plus 2, which equals, let's see, 2 minus 4 is a negative 2. Negative 2 plus 2 is 0. So therefore, when we come back right up here, when x is negative 1, then our y happens to be 0. And what we found is our vertex. Okay, so I'm going to just do a rough sketch right here, x and y axes. That's it. So our vertex is at negative 1, 0. Okay, if we take a look up here, our a is positive, so we know that the parabola is going to open up. I'm not worried about anything else. I just know that it's going to open up. So very, very rough parabola. It's going to look something like this. Most importantly, this right here is my vertex. I know that my axis of symmetry goes right through the vertex. Remember that axis of symmetry is a line. So there is my axis of symmetry. So my axis, the equation of the axis of symmetry is going to be x equals negative 1. And that is my answer. Make sure you don't write just negative 1 because it is an actual line. So it should be an equation. X equals negative 1. And again, all it is just the line, the vertical line that's going through your H right here of your vertex. And this right here is how you find your H. Okay? You know, that's a lot of information I just threw at you. So if you have any questions, then you ask me. Okay? All right.